Let's start with two simple operations on relations, and then we'll go slightly more difficult as we go. Okay, the first one is about the domain of relation and also range of relation. So these are pretty simple, but just to just make sure you actually understand how to operate them. So the domain of a relation, so this is going to be the running example that we're going to use for all the operations. So the domain of a relation R is going to be a set, and the set will contain all the members in the set will be the first elements from relation R. So this is a set comprehension notation, right? As I said before, we got many examples about set comprehension. Please make sure you know the syntax and also you know how to express ideas using set comprehension. Every member in the domain set over here is going to be the first elements of the ordered pair that is a member of the relation, right? That's how you interpret that. Let's now construct this right away, okay? So this is running example of relation, and what we want to compute the first one is the domain. So the domain, that's how you write it, DOM. So the domain of relation R is going to be a set, and the way to think about it is we're going to choose all the first elements. First elements, first one, and first one, right? And notice one thing here. You can see we got A here, and also we got A here. But you don't really include the two instances of A over here. Remember, there's no duplicates for the set, right? So overall, we got A, B, C, and A, B, C, D, E, F, right? That's what we got. You're going to remove the repetition. So we got A, B, C, and repeat it, and also D, and also E, and also F, right? Very simple. That's about the domain of the relation R. Okay, that's the first one. All right, the next one is about for the ASCII syntax. So later on, when we use the rodent tool to actually show to you how to specify and prove refinements about the system, we're going to use the rodent tool. In this case, we're going to type in the domain using ASCII key, using ASCII from your keyboard, the syntax. So it'll be DOM parenthesis R, right? It's straightforward. Just to keep that syntactic reference for you. The next one will be the range of the relation R. And similar to the domain, it's just going to be the second elements of R. Let's look at the set comprehension notation. Every member in the range, every member R in the range is going to be the second elements of the ordered pair that is a member of the relation R, right? Straightforward. Let's take a look. Let me now duplicate this particular relation over here, and let's now put it here. Okay, and we're going to calculate the range. So you spell like RAM. Range of R over here, right? So now it's going to be a set. Every member there is going to be a value of the second elements. So the second element will be 1, 2, 3, 4, 5, 6. 1, 2, 3. Right? We're going to collect them all. And by also remove the duplicate. So we got 1, 2, 3, 4, 5, 6. Right? And all these three we don't need to include in the second time. So it's going to be 1, 2, 3, 4, 5, and 6. Right? So that's the range. Right? You can see it's a very clear distinction between domain and also range. Right? Domain, only the first element in every one of the ordered pair in the relation. For range, the second elements of every ordered pair that's in the relation, or the tuple, the two tuple. Okay, so that's about the range, and the ASCII syntax will be just RAM, right? And that's the example over here. 1, 2, 3, 4, 5, 6, right? As I computed. So the first two operations are very straightforward, just as a warm-up. And also, another one about the inverse. What is really doing what it is written literally. You're going to take the inverse. Okay, but how do we do that? Informally, we are basically going to swap the first and second elements for every ordered pair that's in the relation. So it's going to be the RD, such that DR is actually in the relation, right? It's rather simple. Mathematically speaking, you're going to say R to the power of -1. This might be what you have learned in your earlier math course, right? So this will be the result I'm going to compute together with you. But the ASCII syntax will be R tilde. All right? Let's now take a look over here. And for the inverse, let me make a little more space for myself over here. Let's see. That should be enough. Okay. Okay, let's now calculate the inverse. So we can do all the three operations on a single page. Okay, let's now put another instance of the same relation over here. Let's talk about inverse. Okay, the inverse, mathematically speaking, is going to be r to the power of minus 1, right? So r to the power of minus 1 is going to be another relation, right? You can see the domain is going to be a set of elements. Range is going to be a set of elements. But now r minus 1 is going to be a set of order pairs over here. So now I'm going to say A1 swapped, B2 swapped, C3 swap, and etc. Right? So I'm going to get 1A, right? And then I got 2B, and also I got 3C, and then I got 4A, and also I got 5B. And there's one property which I can show to you in just a moment. Okay, 5B and also 6C and also 1D and also 2E. Be careful. And also 3F. Right? Alright, so that's the inverse. One very simple property you can observe. The domain of the inverse will be exactly the range of the original relation. Can you see? Symmetrically, also for the domain, for the range. Let me write it down for you. So the property you can also definitely observe is like this. So domain of the inverse of R will be just the range of the original relation. Okay, that's one. Property number one. Property number two, symmetrically, the range of the inverse will be the domain of the original relation, right? That was rather simple. The range is going to be A, B, C, A, B, C, D, E, F. What about the domain of the original relation? A, B, C, A, B, C, D, E, F, right? They're exactly the same. So these are the two properties you can definitely observe right away, which I didn't really mention in the slides, but equally good if I mention in the notes over here. 1 and also 2 over here. All right, so that's about the inverse. All right, again, the ASCII syntax will be R tilde. All right, let's now move on to the next operation, which is about the image. So you can think about the image is really to say, given a particular domain value, it may be mapped to multiple values in the range, right? But later on, when we talk about functions, function is a very special kind of a relation. The general relation simply says for every domain value, you may map to multiple range value. For example, you can see A1 over here and also A4 over here, right? You can see the same domain value A is mapped to both 1 and 4. That is acceptable for a general relation. But later on, when we talk about function, in that case, if you have A1 and A4, in that case, it will not be considered as a valid function. Just to some heads up for you. So what's really going to be the definition for image? Okay, so we call the relational image, or sometimes just image. So relational image of relation R over a particular set. So whenever you want to operate on the relational image, you should give it some input set. Okay, it's going to be the sub-range. It's going to return certain range of R that's mapped by every element in the input set, right? That's intuitively speaking. Let's take a look. This is how you write it. It's going to be a square brackets. It looks a little bit like the indexing notation of array, right? You can think about R relation, the image of R over a particular set S, right? S is going to be a set of elements. It's going to be all the range value R such that, first of all, R is actually part of the order pair that's a member of the relation. So here, the domain value over here is going to be D is a member of S. That's actually for sure, because if DR is actually is a member of the relation, it's guaranteed. D is a member of, it's a lower S. I beg your pardon. Let me say that again. The image of the relation R is all such R value such that R together with some domain value D is a member order pair of the relation. And also, D is also a member of the S, right? Because that's the input set over here, right? Again, I'm sorry about confusing you. This is lower S, not capital S, right? Okay, so that's about a formal definition. And we can look at one example, okay? Let's look at AB, okay? Let's take a look. Let me now switch to a new page. Let's now talk about relational image. Okay, so the syntax will be R, the relational image of R over a set, right? So what's the input? AB, okay? A and B. By the way, the assumption, of course, the input over here must be a subset of capital S. Remember, R is actually a member of S, T, right? That's what we assume. In this case, S will just be the domain and T will be the value, right? S will be the domain value and T will be the range values that we are trying to put a relation on. Okay. All right. So let's say what this should be. In this case, it will be visually speaking. Okay, it's going to be so A and B. So let's find out all the pairs with A. Okay, all the pairs with A. So here you can see A here. A will be A, B, and that's it. All right, and then you're going to find a corresponding range value, which would be 1, 2, 4, and 5. Right, so that's the result. So that the value will just be 1, 2, 4, 5. All right, so that's the answer. Hopefully that also is not too bad, right? Okay, 1, 2, 4, 5, and then ASCII syntax will just be using the square brackets, the same as a mathematical notation, which is convenient. All right.